Reenactment of the past. The big question is, why do visionary leaders adapt? The focus question is, how can human analyze transformation based on physics concepts and law in a day-to-day life activity? The outcomes that needs to be covered is able to develop a forward-thinking design based on the understanding of Newton's law of motion and able to analyze a daily life problem based on the principle of work, energy, and power. As we can see in this picture, there is a lot of physics in it. What we can analyze from this picture is a free body diagram. But even if we can apply numerous forces from the free body diagram, the free body diagram only focuses in one object. There is friction against my feet rubbing against the floor. There is normal force when my feet is standing against the floor, and there is gravitational force on how my feet is facing the earth or ground. And as for the Newton's law of motion, the third one is applied, as it is action and reaction. In definition, for every action in an interaction between objects, there is always an equal reaction in return. When the floor is pushing against my feet in return pushes against the floor. To the next picture, as we can see, the bottle is hanging on my hand. Therefore, there is tension in the rope of the bottle, trying to hold on to my hand. Then we have gravitational force because the bottle is facing the earth or ground. In this next picture, we can see the law of inertia. First of all, inertia is a tendency of an object to remain in the same condition, either moving or at rest, when there is no force changing it. As you can see, my cousin is leaning on me. And if she doesn't stand up, I will not be able to stand up either, because of her force or motion that keeps me in place. If we look at this photo, there are a few components that we can analyze. All of them part of the second Newton's law of motion. Force equals to mass times acceleration. The second Newton's law is basically the force of an object is equal to its mass multiplied by its acceleration. First of all, we can see a slide, and then, as we can see, I was going down from the slide. To determine the Newton's second law of motion, as in F equals to mass times acceleration, so let's assume the acceleration is 3 meters per second squared, and my mass in that picture is 32 kilograms. So to count my force, it would be force equals to 3 meters per second squared times 32 kilograms, which results in 96 newtons. Other than that, if we look at this slide in this kind of form, we can analyze the kinetic and potential energy. So potential energy is the energy conserved or restored or has potential to do work. So first of all, to calculate the potential energy, the information that we need is the mass, gravitation, and height. In this case, the mass of my body back then is 32 kilograms, and then the gravitation is 10 meters per second. And then for the height, let's assume the height of the slide is 10 meters. And so to get the potential energy, we multiply 32 with 10 and 10. In results, we get 3,200 joules. Kinetic energy, on the other hand, is an energy possessed by an object due to its motion. And then next we calculate the kinetic energy. So what we need to calculate the kinetic energy is the mass and velocity. In this case, we are starting from the height of 10 meters. Therefore, the velocity is 0 because we start at rest. And to count it is 1 per 2 times mass and times velocity, which equals to 0 joules of kinetic energy, because it is half times 32 times 0. Lastly, regarding the conservation of energy, you can see that there is something in common in the table, which is the total energy of 3,200 joules. But with the height of 5 meters and the speed of 100 meters per second, or if squared into 10 meters per second. So, despite the differences in height and speed, the sum of kinetic energy and potential energy remains the same. This shows that energy cannot be created or destroyed, and that it remains constant despite the interactions it has been through. So as we can see from the beginning of the video, the free body diagram, the Newton's law, and energy all have something in common, which is movement and force. The free body diagram allows us to visualize the forces we have in an object. The Newton's law of motion allows us to see the relationship between the objects and the forces upon it, while energy allows us to see the capacity of an object to do work. Humans work and move every day. Therefore, all these physical concepts are applied in every second of our lives. We can analyze them by taking time and observing the movements we do. All of the mentioned are the explanation and reasoning behind our movement. Lastly, as a visionary leader, we need to adapt in certain situations, which in this case, analyzing forces helps us adapt to multiple problem-solving situations. For example, how to save your energy when doing a huge amount of work.